Last speaker for this segment of the symposium is Bob Corell. A lot of you might actually know Bob. His background is oceanography and engineering. He has degrees from MIT and Scripps Institution of Oceanography. I think probably most people know him from his role as leader of the Arctic Climate Impact Assessment, which came out in 2004, and sort of, I think, at that time really raised the public awareness of what is happening in the Arctic and the speed at which it's happening in a wider circle beyond the scientific community. So Bob continues to work in this capacity, and I think he will now synthesize a lot of what we have presented into a vision forward, because Bob really is a visionary. The first time I got to know him, and that's the last comment I will make to not take too much of your time, was when he shaped the US Global Change Research Program. At that time he was at the National Science Foundation, and he's one of these people who don't take no for an answer easily, and with good outcomes. So I hope he will continue this kind of attitude and will give us some support in our endeavors towards future Arctic studies. Please welcome Bob Corell.
Thank you very much. If we could have the next slide. We're going to have to, there's no clicker that's working, so go ahead and do the next slide. And Peter, thank you, and Olaf, and Eric, Ed, and other. There we are, okay? Next slide, please. Go ahead. I really want to do something with you to try to weave a fabric of these pieces that we've been talking about all this afternoon. And go ahead and click it to the next slide, please. And talk with you about how that fabric weaves together in a way in which all of us on the planet are going to be affected. So I'm going to focus on why the Arctic matters. Sir, can you click the next one, or are we having trouble? There we are. I wanted to ask you, how did we get here? Click, please. This is 800,000 years, and we've never had anything more than about 300 or 270 parts per million. Parts per million is sort of like the GDP of the energy world. But you can see, if we can click it, please, we're already up to 410. That occurred 2 days ago. Go ahead, next slide. I want to show you a little movie, and I'll ask you if you'll next slide, please. We started with less than 1 billion people in 1750. If you look at the year thing, next slide, or next click, next click. Note the year, next click. Note that we start at 2. Next click, next click. And then I want to show you a little time lapse is where all that carbon dioxide has come from in 250 years. So if you watch, it starts in England, as you all know. The energy revolution started there, moved into Europe as we got into the mid-1800s, started to light up over here in the United States. Look at the rest of the world, it's not there yet. Then when we get around 1900, both of those are lighting up. Things start occurring over here. Japan comes on board, South Africa comes on board. About the time I was born, things are really moving. We started at 2. We're already up to 4,000. And we're going to come up to the present, and it gives you some sense. The color frame is over here, the amount of emissions. So if it's red, it's a lot of emissions. So go ahead, next slide, next click. We're up to 10,000. We started at 2, it's up to 10,000. And next click, I hope, tells you we're up to a global population of over 7 billion. And, excuse me, and the CO2 that we just emitted into the atmosphere will be circulating on the planet within a year or 2. So it's a very rapid mixing process. Go ahead, next click. Next click, there we go. Next click, click, 2 clicks. We're going to focus on global impacts. Next click. Why does the Arctic matter to the rest of the world? Why do we here in New York care about what's going on? Why should Tokyo care or Paris? Next click. So we're going to talk about some of the things that have already been on the table, but one of the sleepers that's not really a sleeper, it's a biggie. Next slide, please. Let's worry about this. 4 clicks. As this already told you, we get thermal expansion when anything in a can gets heated up, it rises. We got melting land-based glaciers, but we got some other things that change it. So if you're in the Arctic where there was 2 miles of ice, the land was pushed down, that land is coming back up, so we're not gonna have a lot of sea level rise in Nome, Alaska, for example. And then local currents do change. Next slide, please. Now I want to give you some sense about what's been going on in the last 100, 200 years. Click. 1851, this 70-kilometer long fjord is filled with rubble ice, but at each of these points, the edge of that glacier right over there was here. Next click. Move to here. Next click. And now I want us to look at something really dramatic that happened in September 2015. Next click. Click. I forgot I put this in here. It took 100 years to go that far, only 10 years. So in terms of the question that was oft asked, what's been going on in the last 20 years? Things have really accelerated. Next click. That's the face of that glacier that's melting. Next click. That's a helicopter. So that face is a couple of 100 meters tall. Next click. That's what happens when they calve. The dimensionality of that piece of ice is roughly 1 kilometer across. This has been sped up for your indulgence. Next click. Now, something really went. Next click. This is going to take 2 minutes out of 75 minutes, real time. This is a calving of a glacier that in the past has always done in that clunky way. Now it's doing a clunky way, and this is real time. If you were sitting there, this is what you would see. Some of the dimensions of these, which is hard, that's probably 200 meters from there to here. This is raw footage taken in September when this occurred. Look at that whole piece picking up. So the point I want to make, and I'll let it run in the background, is that things really have accelerated. And Olaf and others have made clear that the acceleration has been dramatic. We're talking about the Arctic seeing temperatures probably we haven't seen for 1 million years. Well, that thing coming up, we did an estimate, it's over 200 meters rising above the surface. That means there's probably 700 meters of ice below. I mean, and this event, when it was all done, took a piece of ice that roughly the size of this Manhattan Island. So it gives you some idea of the magnitude of this. Next slide. So that's one way in which ice from their glacier gets into the ocean and raises sea level. Another way, next slide. We get rushing, melting water coming down into these channels. Next slide. And it does, as Peter was saying, or maybe it was Olaf, drills holes, simply because this water is warm. There's a crack in the ice eventually. And as Peter mentioned, water underneath lubricates it, but it does one other thing. It's buoyancy. It lifts the ice a little, makes it move easier. Next slide. So this I took a picture when I was next issue. Next click. That's about 100 meters. It's one iceberg. Click. 1 kilometer. That's the size of these hunks of ice that are coming in. And we think this is a picture taken just about a month ago. We think that came off of that thing you saw. Next. So next. Now, and you've heard some things, This is kind of the current consensus that towards the end of the century, we're going to see something a little over a meter, maybe 4 feet. Put another way, roughly a foot for every generation, every 25, 30 years. Next slide. So that's sea level, and that affects everybody. The problem is we put this 2100 out there. This sea level, unless, where's Peter? Unless Peter can, his team, pull some of that CO2 out, when the temperature's up there, it will melt for a long, long time. And if we actually stabilize at 2 degrees, it'll melt for about 500 years. And it'll be doing something like a meter or 2 every 100 years. So it's a big deal for societies who live on the coast. And as you probably know, over half of the population on the planet lives within that coastal margin. Next slide. The opening of Seaway was talked about, but let me give you some quickie. Next slide. Until 1950, things were pretty stable. Extent is the area when we look down at it. Next slide. 10% per decade, it's now going down. Next slide. What has changed since 1979? Next slide. Here's the biggie. It's not only the area, but the amount of ice. If you click it for me, we've lost almost 3/4 of the mass of ice. So it's like putting your ice cube in your drink and the drink's kind of warm. It's going to go fast. So this is a big deal, and these are good numbers. Next slide. And what's the consequence of how this whole process works, and Peter and Olaf both, the really old ice is here. This is young ice, 1 or 2 years. It is very soft. And makers of icebreakers say we can go through that pretty much year-round. Next slide. That's the picture. Next slide. All right, so what's going on? And I think this was implied by almost everyone. We're in a position where natural resources are really an attractive issue, and the prospect of international shipping is going to open up. But Korea, Japan have dramatically increased their interest. You know why? Those 3 countries had last year billed 92% of all ships that went to sea over 100 tons. 100 tons is a small vessel. Go ahead. Next slide. So if you'll click through these for me, this is why. Trade, hydrocarbons, hard minerals. One more. One more click. There we are. These are the biggies. Every cell phone in this room has something from here. The other 75% of that is mostly in China. So there's a big issue evolving for interest in getting some of the rare earths. Go ahead. So let's go to weather. I think everybody in the room knows there have been weather changes. Next click, please. Why does the weather go the way it goes? Next. Some trends. Do another 2 clicks. Things are happening. When we call a hydrologic cycle, that's how water gets moved around, made into ice and clouds and the like. But look at this in the United States. We've had a 30% increase of intense rain, even though the overall amount of water has come down. It's not very much. New, just 2 or 3%. But all those rivers used to be carved over a 10,000-year period, and they can't handle it. Next. This is what the jet stream looks like from the top. You can see Greenland. And I'm going to go quickly to the next slide. Next click. Next click. So 2 things are happening. This jet stream is stretching out. I live down here. I took a flight down, which normally takes to go to Washington about 3 hours. We went 1.5 hours. We got in that jet stream because it had gotten all the way that far south. But you see, when it stepped down, we pull cold air here, warm air here, totally changes the whole weather system. Next slide. Let's go to acidification of the ocean. I'll try to go really fast, Peter. But this is, for me, another hidden one. And it was buried in some of the things Alf Holkman was talking about. Next slide. Next click. We have not seen the projected changes in acidification of the ocean for over 65 million years that we actually have right now. And why is that? CO2 is just sitting on the water, gets sucked in, gets converted to carbonic acid, and the next is history. Go ahead. Next slide. Next, click, click. Things are happening up here because cold water holds more CO2. I call it the Coke bottle effect. Next slide. Next. 1, 2, 3. I should let Al Falcon talk about this. You see what they call the pteropods? The potato chips of the sea. They're so central to the food web and affect some of our most important fisheries like the North. Next slide. And here's where we're going. Bingo, bingo. Next slide. That's where we are. That's where we're headed. And we have not been there for at least 65 million. Okay. What, it's not working? Oh, okay. I don't know whether I'm on it. Go ahead, next slide. I want to just say one little movie from thawing. Go ahead. I think it was Mary Beth who showed a little corner, but I'm going to show it live. Next. There's Kathy, Katie Walters. That's on a lake in Russia. All they did was make a hole. Boom. So you get some idea. We're not talking trivia because if this really blows, next slide. This is what we see. Next slide. Bingo, bingo, bingo. Methane is so much more powerful, the greenhouse gas, that if it gets really going, things are serious. Next slide. So, this is just a quick summary, but I want to hit the last. Let's go to the next slide really left. Go ahead. Next. Serious consequences. Next. Go ahead. This is a diagram with 5 degrees at the top, and if you click through them pretty rapidly, you'll see first, click. That's where we are. Click. That's where we're going. Click. That's where we're likely to go fairly quickly. And bingo. Next slide. One more. That's where we're likely to go. And that 3+ degrees, it gets multiplied by 2 or 2.5. Next slide. Go ahead. Now, this is the bad one. If we do not do anything, business as usual, and this is all corrected for amplification of demand, we're going to be at 2 degrees by 2040. If we put the Paris Agreement in, this will slide 10 years. That's if we don't do things. Next slide. One more. Bingo. So, what's going to happen to the world? A lot of people are going to become in the middle class, and they're going to want more stuff. Next slide. Go ahead. And we in the United States try to characterize what things are out 10, 20, 30 years. You get some idea. Major changes in the economy. Technology is going to be there, but it's going to cause dislocations. Next slide. A couple more. Governing is going to be more difficult. I think this fits into every one of the speakers. Last slide. Next slide. And now, this is an experiment. If everybody on the planet agreed to take down their emissions at the same rate, what would it take to get us to 2 degrees? If we start right now, it's 1.5%. That means we have to replace 400 plus power plants who now use fossil fuels with some other non-fossil fuel. And the cost of that, if we do it now, is of the order of $300 to $700 billion per year until 2100. One more. Next slide. Now if we go out to 2030, now we're going to do 1,500 of those every year. Bingo. Next slide. Bing. The last one. We're now playing around in trillions of dollars per year based on the cost of these replacements today, and the GDP of the planet is pretty substantial. But if we wait to 2040, those numbers go up by a factor of 5. Next slide. So I have a concluding thought, and I think it was buried in all of our presentations. We are abhorrent to change. We're repugnant with the idea that we have to readjust. One of the great economists of our century told us this 80 years ago.